All right, welcome to today's lesson. We're going to look at transformations of points. Now, it's going to be really easy to get lost in all the new notation you might come across, so just take it slow and we'll get through this. All right, so the first thing we're going to look at is a bit of a Desmos graph that I've created. I'll do that. We're going to have a look at a point. All right, so I'll turn on this graph. And here you can see a point. There's 2 points, and what you're looking at here is there's 1 point there, another point which is on the same spot, and a net zero is showing you the length of the distance between the 2 points. All right, so what I can do is where we can drag one of the points. So there's 2 points currently, but we're going to drag one out. So I'll get my clicker back, and I can drag it only horizontally. That's why I've named this folder in the Desmos thing horizontal. So you can see that the drag is making it further or closer together, and that's changing the distance between the 2 points. Now what we're concerned with today is how we can make 1 point become another point. So I'm going to show you some notation. So this original point here is going to be called x, y. And the second point is going to be called the image of the first point. So the location is currently that, but its notation is going to be x, and it's basically an apostrophe, comma, y apostrophe. And the way you read it is x image, comma, y image. And when we say image, if you think back to your geometry, what that means is it's the second one of the same thing. So somehow this first point has been transformed to become this second point. All right, so this first point has become transformed into the second point, and the way we do that, you can see, is just by dragging it horizontally. All right, so what we're concerned with here is the change that's happened. So you can pretty clearly see that the first point has been moved 10 units, oops, not like that, has been moved 10 units horizontally, and the y value has not changed. So we would show that in the brackets by adding 10, comma, the same y value. All right, and that will simplify out to 6, comma, y. All right, so then we can see that the y value is the same. We can see that the new x value is 6. All right, so some special notation here is that the image equals 6. The original y value is the same as the old y value, so we can put it like this. All right, so another way of writing it is that the original plus 10 equals the image, and the original of the y values equals the image. So you can see there that the original plus 10 is the same as the image, and the y values are just the same as each other, which is why I was able to write this line here. All right, minus 4 plus 10, comma, y, which is just these parts substituted in place of x and y. So this is the change that's happened. This plus 10 here is the change that's happened, or the transformation. All right, so we'll do another transformation and we'll write some stuff down and have a look at it. All right, so I've put the points back together. I'm just going to get rid of these calculations. Don't worry, you can just rewind the video if you're worried about losing them, and pause it and rewrite and write them down. So what we'll do is we'll have a look at a transformation that's slightly different this time. We'll drag the first point away from to the left of the original point. All right, so for this point here, you can see that the change is 7 units to the left. So we'll write down the original point as x, comma, y, which we know was 2, comma, 4. All right, now the change that's happened, we've taken it 7 units left, which we know is a minus. So x minus 7 equals the image. And we also know that the y value didn't change, so the original y value equals the image y value. So then we can check our work by looking at the graph. We can just substitute in 2 minus 7 for x, calculate the image, and the y values will stay the same. So then the new point is going to be minus 5, comma, 4. Oops, I put an image there. All right, so you can see this is the same point as what's on the screen here. All right, so that's two examples using horizontal translation. Let's have a look at one using vertical translation. Just erase this. Okay, so we've got 2 points here, and I'm just going to erase this writing here. We've got 2 points here. One we haven't moved yet. So we'll move it vertically upwards, and I've locked out the horizontal translation so we can not worry about that. So first thing is I want to know how far it's gone, so I'll count the boxes. 1, 2, 3, 4, 5. It's gone 5 upwards. All right, so what we're going to need to do is record the original point, which is xy, and we'll record it as 3, 4. All right, so we can actually show now the transformation that has occurred, and we already know it's vertical, and we know it affects the y coordinate, but not the x coordinate. So we can pretty simply say that the x coordinate doesn't change, but that the y coordinate, which goes up 5, is now the new coordinate. So we can say to ourselves that 3 equals the image, and that 4 plus 5 equals the image. So then that's going to give us 9. I won't write it like that. It looks like division, doesn't it? So I've got the new point is 3, 9, which we can confirm by looking at the graph. All right, we'll do one more example and then we'll look at a combination of them. I'll just delete those workings there. We'll click back into our graph here. We'll put the points back on top of each other and we'll drag it, I reckon, down. We'll drag it down that many units. Okay, so having a look at the transformation that's occurred, we'll write down the original point as xy, which was again 3, 4. We can see that the x coordinate remains the same, so x equals the image. We can also see that it's been moved down this time, and it's been moved down by 8 units. So we can say that y minus 8 equals the image. Now it's important that you don't write that as a 1 because it might be seen as a power. So make sure it's an apostrophe. So first of all, we've got 3 equals the image of x, and then we've got 4 minus 8 equals the image of y. So that's going to give us a new coordinate of 3 minus 4, which we can confirm by looking at the graph also. So important things to remember here are that we can translate individual points using horizontal and vertical combinations. And the horizontal combination or horizontal translation affects the x coordinate. The vertical translation affects the y coordinate. All right, and the way we show that is that we use the apostrophe mark to indicate that it's been moved and is therefore an image of the original x or y value. All right, so the final thing we'll look at for this little part of the lesson is combinations of transformations. So I've got 2 points on the screen and they're on top of each other. So we're going to move one of them away from the other. And the one I move is going to be called the image. All right, so I'll show you what I've set up to happen here. We can see when I move this, I'm going to move the point up to around here at 5, 5, and you can show me, or you can tell me what you think, what you see happening. So it's moved up to 5, 5, and you can see that there is a horizontal component and a vertical component. So there's no straight diagonal movement. It goes horizontally first and then vertically, or vice versa. All right, so that makes it easy for us to calculate the images of the original point. So first of all, we're going to write down the original point, which we can see is at 2, 1. And then I can see that there's been a horizontal translation and it's gone 3 units across to the right. So x plus 3 equals the image. I can see there's been a vertical translation, so it's gone 4 units up. So that's y plus 4 equals the new image. And then we just substitute in what we already know. So this 2, 1 gets put in place of x and y. So 2 plus 3 equals the image. 1 plus 4 equals the image. And you can see here that 5 equals the new x image and 5 equals the new y image, which is what we knew from the graph. So the new point has been moved to 0.55. All right. The important thing you need to remember is this notation and how to write the transformation using the original x and y values. All right, let's try one more just to practice our notation a little bit. I've reset the points, so we'll drag it in a different direction and see what changes occur. So I'll drag it left and now I'll go up, put it there. All right, so first of all, let's record the location of the first point, which is at, again, it's at 2, 1. All right, and now this time it's been dragged left, and it's been dragged left by 1, 2, 3, 4, 5, 6 units. So we can say x minus 6 equals the image of x, and it's been dragged vertically upwards, and it's been dragged, which means it's a positive change. 1, 2, 3, 4, 5, 6 also equals the y image. Then we substitute in what we know. 2 minus 6 equals the image, and 1 plus 6 equals the y image, which gives us a final x value of minus 4 and a final y value of 7. So we can write the coordinate point here as minus 4, 7, which does make sense when looking at the graph. All right, so the final thing I wanted to show you is a way that the book and mathematicians tend to write down these series of transformations. And the way they'll do it is they'll say something like this. So x comma y, they'll use this arrow, and this arrow means sort of yields, like in chemistry, or technically here it means maps to, and they'll say it's x plus h comma y plus k. So you can see we're getting back to these variables which we know from transformations of functions. We know that the h value does horizontal translation, the k value does vertical translation. All right, so what this is telling you is that this original point maps to this point, which has been translated horizontally and translated vertically. And you can read this as the image under these transformations. All right, so you would say that x plus h equaled that, which we did from the examples, and y plus k equaled that. So this is just a fancy way of saying everything we've done in a different format. All right, so it's valuable to remember that. Now, there are some key differences here in that notice that these are both plus signs in the plus h and plus k. All right, and this means that it goes right, and mathematicians show you the converse one as well. So this will be xy maps to x minus h comma y minus k. All right, it doesn't make a major difference, but it does mean that you're thinking about the direction that the transformation has happened in. All right, so keep that in mind as you move forward. This is another way of telling you what the transformation should be. So for instance, for this example here, if we wrote it in this notation, it would have looked like this. It would have said that the original point 2, 1 mapped to x minus 6 comma y plus 6. And that would mean that you were looking at the transformation that happened to this point when these changes occurred. And you would use this knowledge to read the changes off it and apply them just like we did here.